morning or good afternoon, wherever you are joining from. Just as a quick introduction, my name is Gerard Marsh, and I work for Bentley Systems, and specifically, I work in our reality modeling department, working on all things reality modeling, and especially all things context capture, and it's context capture, which I'm going to just run through some more slides on today, talk a little bit about what context capture is and where it sits within Bentley. As a role, I'm an application engineer at Bentley, so that's a technical role. So hopefully, if there's any questions as well, we can maybe go through some of them. That happens. So the first thing is what is reality modeling? So reality modeling is a term within Bentley, and the idea is it's capturing existing conditions in 3D using one or a combination of different devices. And then reality modeling, it tries to sit and support a number of different applications. And it can be mapping, its design, its construction, its inspection, asset management. So there's not only just one place where reality modeling sits, we see it sitting across the board when it comes to all engineering disciplines. And the main piece, one of the main pieces for reality modeling and what makes up a lot of sort of the backbone and the base map of reality modeling is context capture. And just to give you an idea of what context capture is context capture is a French company that was acquired by Bentley around about 5 or 6 years ago now. At the time it was called Acute 3D. It's based in France. And what they did is they created, they took 2D images and created 3D models. So the idea was you fed in these 2D images, whether they were dumb images with no information at all, or they had lots of intelligence to them in terms of metadata. And these images were loaded in, then through photogrammetry techniques, they were producing accurate as-built georeference 3D models. So they were using producing a range of different CAD formats such as STL, OBJs, FBXs. They were also taking these images and creating point clouds as well. And the main big point that they had was these innovative multi-resolution meshes as well. So the 3MX and 3SM. So the idea with this was, as you can see at the bottom there, is you can produce any models of any size optimized for web publishing, and they could be shown on your mobile phone, on your laptop. And when we say any models of any size, these multi-resolution meshes, and the way they work is the idea is that you can have a full city model being shown on a mobile phone. As you zoom in, the level of detail on that city model increases. As you zoom out, the level of detail decreases. So it makes it really nice and smooth for streaming. And as these are, as built georeference 3D models, you can geo-coordinate your projects, you can accurately measure coordinates, distances, areas and volumes. You can obviously also merge them in with any other projects you're already working on that geo-referenced as well. So great piece of software came in, obviously photos to 3D models. And this was around about 5 or 6 years ago now when this was acquired. Ever since Bentley's obviously acquired Acute 3D, it's now obviously changed its name. It's now called ContextCapture. There is a new release now, ContextCapture, every quarter. So obviously the development cycle's picked up very fast now. We're trying to move it on in terms of technology at a very quick rate. And what originally was ContextCapture was Acute 3D and originally a photogrammetry software. It's now turned into a reality modeling software. And the reason why we call it reality modeling software is the fact it's not just based on 2D images anymore. So what you can do now is you can not only just load your 2D images into ContextCapture, you can also load in any laser scan data that you may have to help create your reality meshes. So what we have on the right here is from an industrial site. This is a little screen grab of a reality mesh that was created. And how that was created was we flew a drone over the top of the site to capture some images to give the general overview of the site and what's there. We then used a static laser scanner with a number of points to go around the equipment, around the vessels, etc., to capture some more of the hard geometry data. And then we also went around with a DSLR camera and we just took some images as well to get that visual detail, to get them tag numbers, etc., things like that, to get an idea of the condition of the assets as well. And what we then did is we then took all this data, so the 2D images from the drone, 2D images from the camera, all that 3D data from the laser scanner. We loaded it all into a single project, and we produced a complete reality mesh of this site. This was a completely geo-referenced, very, very accurate reality mesh. Obviously, the laser scan data gave a lot of very accurate geometry. The image data from the drone and the DSLR cameras also helped with the accuracy of the geometry, but it also gave that complete visual detail of being able to see the condition as well of all your assets. So as I said, you know, ever since, not just for Grant anymore, wide range of acquisition devices, many different acquisition devices. You can keep throwing as many different devices into a single project as you like. And as I said before, it's all about unlimited scalability. So it's all about meshes, reality models of any size that you want. So to give you an idea, this one on the left is a small site in Germany for Siemens. This was 1,250 photos taken from a drone, again, to get that general view of the site. Someone went around with a DSLR camera to get 2,500 photos from the ground. And then also they went out and they took 25 scans as well, using a static laser scanner to get some more further detail in. Same idea as before, you saw me the picture before, sorry, that screen grab is this was then all processed within ContextCapture as a single project, and you get this complete accurate overview of your site. But this is more the smaller scales. This is single sites, and it doesn't have to just be single sites as well. It could be single assets. It could be just a single stockpile. When it comes to civil works, it could be a single sort of electric cabinet if you're doing any kind of reviews for utilities, services, things like that. Or it can be a single site as you have here. And then the joys is the same computing power can go and actually create complete city scale models as well. So great thing about ContextCapture is this flexibility and this unlimited scalability that you can actually create small single sites, single assets, and then you can go all the way to complete city scale models of any size. So we actually have users who are, as you see here from Aerometrics, but another one who are creating complete cities. They've done Washington, they've done New York, they've done, I think it's some other ones as well, I can't think off the top of my head, but they've done a number of the big city states in America. And again, all through ContextCapture, it can be as small or as big as you like. And the way it's done as well is through the way that we have these different packages. So different packages obviously meet different people's different needs. We also have a cloud version as well. That cloud version is, you know, because ContextCapture can be quite heavy on hardware when it is processing. So we do have a cloud version as well. And that cloud version will help you to do some processing, takes all that work away from your own hardware, pushes it to our cloud, processes it, and gives it back to you. Again, a great way for sort of trying to speed things up a little bit, you know, not having to invest in your own hardware. But at the same time, we do have complete desktop versions as well. And just to give you an idea of what you're kind of getting from your processing, it's just a little table here just made up of just kind of what breaks down into gigapixels, etc., and what kind of thing you get in gigapixels. We are seeing actual higher speeds recently. This table is quite old for one I did. So as a portfolio as well, just give you a quick idea of it all. Obviously in the capturing side and the processing side, we do have, as we just showed them, we do have a cloud processing version of ContextCapture as well as complete desktop versions. The cloud versions also has a cool little mobile application called ContextCapture Mobile. Same sort of idea as you have with any kind of cloud product. You take your pictures, you upload to the cloud and it processes, but it's coming straight from your mobile application rather than from a standalone camera. And then in terms of editing and extracting as well, we do have some kind of CAD tools available, we'd call them in that kind of sense, ContextCapture Editor, based on the MicroStation platform. We obviously have Descartes again, based on MicroStation platform, loads of really cool tools in there, lots of tools that have been pushed towards reality modeling and help you work a lot of your civil workflows, any kind of inspection workflows, things like that in a CAD environment. And then we also have a complete online storage as well. So ProjectWise Context Share, great way for if you've got many meshes / React models / point clouds, great way to store all this data in a cloud environment, be able to view it all online, be able to share it with your colleagues, be able to share externally, and also just take that burden of having lots of disk space taken up locally on the cloud instead. So if anyone who's never seen it before, I was just going to run through the two sort of workflows for ContextCapture Desktop and ContextCapture Cloud, just to show you how easy ContextCapture is to work with, some of the results that you get as well when you have worked with it. Oh, wrong button. So to start with, if we're just working with images alone, there are some, and I always like to just stop this, there are some basic, obviously, principles when it comes to photogrammetry and how you acquire your photographs. So the first piece is obviously we require a minimum of 60 to 70% overlap between two consecutive photos. Each point, so each point is in like the corner of a building or the corner of a window or anything like that, must be seen in a minimum of at least 3 photographs. And there's a maximum border angle of 15 to 20 degrees. The reason for this is obviously what the software has to do is it has to take these dumb 2D images. It then has to pick out points in the images, move to the next image, pick out the same point again, and then work out through triangulation the position, the rotation of them images. Hence the reason why if you nicely follow these points like this, you get a really nice swooping loops with your drone. You get some really good results out with lots of automation and context capture. So obviously what he does is he finishes doing his loops around his building here. He then comes in, this is what the software looks like. I'm just going to pause again in a minute. He drops his photos straight, as you can see, it's from a DJI camera. Oh, and I'm just going to go back a little bit. And what happens is as soon as you drop them photos in, the software will actually recognize straight away how many photos obviously you've dropped in. It'll read from the metadata of the camera that obviously it was. So it was a DJI FC350 camera. It'll have the sensor size and focal length to help work out everything out. And also, as you can see, it's obviously had some GPS data that's been loaded in here as well. So it's got some metadata from the images. So it's taken that in to help the software actually georeference it. And then what happens again is it does skip a little step actually in this video, is what happened is it did run an error triangulation. And once that error triangulation's run, it pulls all these key points. So obviously it positions, rotates correctly in a coordinate system, these images, pulls out all the key points, and then it's ready for what's called reconstruction. So turning all these little dots into an actual complete visual reality mesh. AT, the reason why it skips this step is completely automated. So once you've run the AT, is automated, it then goes into reconstruction. You put a nice little bounding box around it saying, this is my area of interest, this is how I want, what I want to produce. You then split that into tiles, so depending on what you have available from your desktop or your laptop, you'll split into tiles, you'll submit the production, and it'll start creating all them little tiles for you. And then once it's complete, you've got a complete 3D reality mesh like so, all stitched back together nicely as one piece. And as I said to you before, really easy, really nice to work with, complete georeferencing, and it can load straight into your CAD platforms, and you can start doing, this just shows some very basic workflows for elevations and things like that, but you can do many different workflows, including stockpile volumes. You can do new designs on top. It is a completely snappable mesh in that sense, and correctly scaled too. So really, see what you saw there was 3 main steps: capturing your images, loading in error triangulation, reconstruction. And most 90% of that work's all automated. It's only 10% maybe is manual input, very small manual input. The rest is just the computer processing a way to create the reality meshes. So in that sense, not much work on your side at all, and you can get some really nice, highly visual reality meshes out the other end. So as well as the desktop, we do have a cloud service as well. Like I said before, the reason why I do show the cloud workflow as well is it is a little bit different in a sense that the user interface is a little bit different, a little bit more sleek, I guess, in a word. And just once we just get through a couple of these bits of marketing shots here, we'll get a look into what that looks like. So here's someone going up from the drone to reality mesh of a bridge. What will happen once they take the images, they'll drop them into ContextCapture, what we call console. So this is the actual cloud one. So you're still working on a local user interface just to get all your work prepared. He loads all his images in, just checks his images look correct. And then once he's ready, he says, right, that's it. There's a lot more options now available. But he says, okay, you get different speed factors. So he's like, oh, this is really important. I want it as quick as possible. Uploads. And this video does skip quite quick. Once the images are uploaded, he walks away, he shuts everything down, he gets back in his car and he drives back to his office. And after, as you can see here, after 2 hours, he gets an email through saying that his mesh is ready. He can view it in a web browser, or he can just go and download the files from the link if he wants to. So he clicks the link and here it is. So what he has here, this is Context Share. All his models that have been created are nicely stored there. His inputs, all his image data is nicely zipped up and archived for him, ready for if he wants to use it again. Here he's got his web link to his reality mesh online. And then here we've got FreeMX and FreeSM, which is for him to download a local copy and work with if he wanted to. But here it is for a start in the web viewer. And as you can see, in a couple of hours, he's got a complete reconstruction of his bridge. It is georeferenced. He can take some measurements from it. He can share this link and add people to the project as well, and you can have them take a look at the same thing. Or as you saw before, you can download it as well. And if you decided to download it, then you can then use it within a number of range of different CAD softwares. So what are some of the features that we've been talking about that really make a differentiated sort of thing with ContextCapture is the first piece is the hybrid input. So as I said before, ContextCapture is not just a photogrammetry software. When we first acquired, obviously, Cube3D, there was many meetings where we would sit in, and there'd be a lot of time where people would be discussing which one is the best way to capture an existing site in 3D, capture existing terrain in 3D, things like that. And there'd be many conversations, whether it's photogrammetry, whether it's laser scanning. So what we came in with is hybrid modeling. So the idea with hybrid modeling is, depending on the scenario that you have, is depending on the type of 3D acquisition you will do and what you want at the end. So ContextCapture now has 4 ways of creating reality models, and then 4 ways are all there to try and improve people's workflows, try and help them capture their 3D data accurately, precisely, and as quick as they can, depending on what kind of workflow they want. So the first way is the photogrammetry, so it's images only. So we can load our images in. We can then obviously process these into a reality mesh. The other way is, if you've already got loads of laser scans, static laser scans, mobile laser scans, so not just laser scans from tripods, but if you've got any laser scans from car mounted or train mounted, or can it be plane mounted, we can load them mobile scans and them static scans in and take them straight to a reality mesh. So some people sometimes think that laser scan data, although it's very accurate, etc., and very precise, sometimes they think what doesn't help with laser scan data is the fact that it's not very visual, it's not very easy to interpret. So you can load them point clouds straight in, laser scans straight in, turn them into a reality mesh on their own if you want. The next way, which is the main way for hybrid modeling that we see a lot of people doing, is point clouds and imagery combined. So the idea with this is, as you saw in that one of the very first slides, is we go out, we capture some scan data of the site, we also overlap that scan data with some image data, and then we produce it all together. So the idea there is the photogrammetry side and the laser scan side both come together to try and give the best fit. So there's no gaps, everything fills in. You get some images in areas where you might not be able to get your laser scanner. Your laser scanner helps get some of your geometry where the images might have struggled a little bit, etc. And you get this perfect mesh. And then the final one, which is one that's come quite common right now is some people might have some laser scans already, or they've gone and captured their site with very, very high levels of detail with their laser scans. What they can do is they can take them laser scans, turn that into a mesh. So they're getting them perfect straight edges, lines everywhere. They know it's all well captured. And then they can just go and grab some very, very basic images. Then basic images could be from an iPhone, could be from a DSLR camera, from a drone, etc. And all they want to do is they just want to use them not to help the actual geometry or not to fill in any geometry in the reality mesh. They just want to use it to make sure that they get very, very high levels of visual detail within their reality mesh. So what they can do is they use the last option, which is the point clouds used to actually create the geometry, create the mesh itself, and the images are just used for a texture map only. So they're just overlaid on top to help with them kind of like tag number readings, things like that. And just going off what I was saying before, is this is just an idea of how you can see the difference between a point on its own and when we have point clouds and images combined. So obviously, as I said before, the images are helping to fill in the gaps where the point cloud maybe couldn't get any coverage. Not only that, it's helping giving you this unbelievable amount of visual detail. So in terms of defect detections, cracks, it could be any types of signage that's around, any tag numbers, tag plates that you might have on your equipment. If you get the images in the correct ways, you can even read any kind of displays along the way as well. And as this drops in there. But a great one here again is that coverage. So what I think it tells the best here is, as you can see, the laser scanner couldn't get in, it couldn't see in, obviously, to get the coverage with inside where the pump is. So by just getting a few images around the perimeter there, leaning in, we can then fill in all that detail that the laser scanner couldn't get. We can then obviously turn all that detail into a mesh, and then you get a full idea of what that site is. You can work out what that site is. You can review that site very, very easily. The next big sort of feature is, as I said before, is our multi-resolution meshes. So the great thing about our multi-resolution meshes, so our 3SMs, which are our scalable mesh file format, is this multiple level of detail, and the idea of, as you zoom in, you zoom out, the level of detail picks up, and also the idea being, as well as being a multi-resolution mesh, is that you can have high levels of detail in some areas and low levels of detail in other areas, all in a single mesh. It doesn't have to be a single range resolution across the mesh. And just to give you an idea, this little clip is what we have on the left is a 3D mesh without any levels of detail, and on the right we have Bentley's scalable 3SM. I'm just going to play that again, just to let you see how much difference, how much crisper the detail is, how different it is to without having levels of detail at all. Final little feature piece that I just want to show as well is our splats and photo navigation. So this is a big thing for anyone who's ever used any type of photogrammetry software before. It's a great way for doing a quality control for your arrow triangulation, but also getting a draft 3D scene. So I just want to make sure that everyone's aware as well. This is not an output mesh. This is actually a interim stage, part of your arrow triangulation, called splats. And what used to happen is when you'd run an arrow triangulation in any photogrammetry software, you just have lots of little what's called key points, which would make up your scene. And before you reconstructed, you'd struggle to work out, you know, is everything looking correct? Is the detail correct? Have I got any bits that I've missed or any fill in anywhere? This is where splats come in. So splats, what they do is they put a little thumbnail basically on your key points. Great way then for you to do any kind of measurements on top. But the greatest thing about splats is, as you can see, and especially when you've got like things like terrain modeling, it really helps fill out that detail and give an idea of what's my mesh going to look like when I do an actual reconstruction, when I create an actual reality mesh. And as you can see there, it's really helping the user work out, okay, things look all right there. And to add to that, he also has photo navigation. So what you can actually do is you can actually go around here, and either on the left in the splat or on the right on the image, you can click at any point. It'll obviously highlight it in the photos and say, okay, this is your point. So it's a great little inspection tool as well. So for any inspection work, if they're not actually interested in maybe going into a complete reality mesh, they can actually just come in, triangulate their images to work out what they are, and just use it for inspections, review inspections, things like that, review any defects along the way. As you can see, just click on the splat, he's zooming in now, he moves around, it shows the different images that look at that area. And in the same way as he was clicking on the splat, you can also click on the photo itself and it actually zooms to it in the splat. So it's a real great way of looking at and reviewing your site and just reviewing your area of triangulation, or reviewing actual photos as well. So just want to say, obviously, remember it's one sensor, or all sensors in a single mesh. It's the great, obviously, thing with ConTextCapture, and it's obviously its openness, is the fact is you can just keep going back. It's all about continuous surveying. It's all about continuously updating your reality meshes. It's throwing as many different sources of imagery and laser scan as you can, making sure that you get all the correct coverage you need depending on the application you want. And there is no limits on that, on how many sort of pieces you can put into the single reality mesh. So what I need to go through now is just to kind of like start to finish this off a bit slowly, is just a few use cases for obviously civil, in a sense, for how we see users using it, and civil use cases, what they're doing with it, and also a little bit of what's coming in the future with reality modeling and ConTextCapture as well. So the first one here, I think is a great use case. So what happened here is a survey partner had gone out, they'd captured some images of a highway overpass in America. I'm just going to slow this down a little bit, it's quite fast for you. And he gets back to the office, or while he's out on site, he pushed all his images in the ConTextCapture cloud and he produced a reality mesh of this junction. And the idea with this junction is, what we want to do is, he said, okay, this is the junction design as it is at the moment. What I do is I need to know the general overview. So he wasn't interested in having a very high detailed image, but what he did want is a really, really good terrain model, an idea of the general existing brownfield site, so then he could work out a new design for his overpass. And once that reality mesh was created, as you can see here, it was loaded straight into Bentley's Open Roads Concept Station, or road design. And what he does here is he actually goes and, using a tool called quick ground extraction, is he actually goes and highlights that whole junction area like so, and he clicks go. And what happens here is, once he clicks go, is what the actual software is doing is it's turning around and it's going to say, I'm going to flatten that whole 3D area in what's we call 2.5D, so into an actual terrain. So then once it's flattened to a terrain, he can work on that accurate terrain and do his new highway design on top. So you can see, just makes a couple of little small changes as well, make sure it's just on the junction, does that ground extraction. And what it does skip to then is he's actually then gone in Concept Station, he's managed to draw a new concept for the actual road design itself, and then even gone further into then adding some animation through LumenRT. And what you can see here for his animation, he actually goes then and does actual traffic as well on top. And very quickly, so, you know, in not very long at all, he's managed to go, he's managed to capture that site, he's managed to get a big, large overview of what's in the area, what the terrain's made up of. He's then managed to come straight into Concept Station. In Concept Station, he's managed to flatten, to do a ground extraction straight on that piece of, on that highway, flatten the whole existing highway down to a terrain model, and then build his new concept on top to say, okay, so my concept design is what we're thinking, and actually then animate it as well to actually show what it would look like with running traffic. Very, very simple workflow, but very, very powerful workflow. And it just shows how ConTextCapture gives you that complete overview base map, what you'd need for your new designs. Next one here is showing it more from a construction point of view, but it's a great way of showing that, you know, again, complete city model. And what we have here is we have our city model and we have our new building design. What they're showing here is obviously the 3D model for the building, and then what happened is every couple of weeks, I went out again with the drone and they flew the building site. And what they want to do is they want to check against their as planned stages for construction against what the site's looking like right now. And in a real simple way, as you can see here, and again, just to show the powerfulness of the streamability and the working of these city models, you've got a complete reality model city mesh, and just in the middle here, they're showing how the building, obviously in their construction modules, look against where they actually are for an as-built, and obviously it makes the way up. Here, and I think in a moment, if I remember rightly, it does get to a point where it shows there is a bit of a delta error and they are actually a little bit behind on where they expect to be. Sorry, it's actually a different video, but yeah. But here just gives you a great idea to show the new building, and obviously as you can see, it is in that complete reality mesh scenario. You know, this could be working, and I've seen it working on just on people's laptops. You don't need very heavy, big hardware to be working with these reality meshes once they've been created. The flexibility of them is so much. Another great, really powerful piece is what we see a lot of people doing is stockpile surveys. So what they'll do here is they'll go out when it comes to things like mining, or it comes to things like any kind of civil works, kind of road works, things like that. People want to know at the moment is how much they're getting charged for stockpile removals, or how much stockpile they've got, etc. So what's an easy way is you go out again. Here, this was a mining company. They were sending out a drone. I think it was every 2 or 4 weeks, capturing the site in the same grid pattern. And then what they were doing is they were coming in then into what's called ContextCapture Viewer, which is our free viewer. And really quickly, they were just going in, zooming in, and they were able to, there's an actual volume calculation tool, like so, quickly snapping around, and they were getting, for them, which was really good, stockpile analysis. You know, they didn't need it to be perfect, they just wanted to get a good idea of what their volumes were of their stockpiles. Not much manual work whatsoever, but really, really powerful, quick results for them that they were very happy with. Made life much easier. It's less dangerous as well. Obviously, people aren't having to go around trying to measure stockpiles themselves. The drone goes over the site every, say, 2 weeks, 4 weeks, whatever that may be, captures the site in the same way. They produce a reality mesh, and then someone sits in the safety of their office and can do all their stockpile analysis, all their stockpile measurements without leaving the desk. Another piece here is the mobile inspection. So what I show is obviously this is actual ContextCapture mobile itself. So someone goes out with their mobile phone. What you just saw there is they just put a tape measure down just so they could actually scale their little inspection work to make sure it's actually correctly scaled, so measure from it. Goes and takes some images underneath the bridge here. He's actually want to concentrate obviously on the actual defect, the crack underneath. He loads these photos into ContextCapture, and then as you can see before, he'd walk away, turn his mobile off if he wanted to, and someone in the office would get the link. Once that link's in, they then take it straight into ContextCapture, into Bentley Descartes. This actually streams in there as well, the reality mesh, and he can start doing some general quick sort of review work, depth, things like that, the crack. And he can also, if he had any existing ideas, designs for the bridge behind, you could actually overlay them as well to see, get an idea of what they are with that defect. And then a final piece, it's obviously not as much civil, it's more an industrial type, but it's a great way to show some of the powerful tools we have, and a great way to show as well how detailed reality meshes can be, in a sense of more on the sort of visual operations, the asset management kind of side of things. So here we have a reality mesh. Again, that sort of great thing that you see the general condition through the visuals from the images. And what we can do is, using our reality mesh is that kind of that insight, that window into the condition of your asset. with some more detailed on top of that, we can really easily start and do searches. We can classify the reality mesh. So here we can actually look up anything that might be there. So here we looked at pumps. So all this classification had been done. The reality mesh then shows people where them pumps are, what their labels may be, you know, display any asset information that we add to them as well. So tag numbers, descriptions, any engineering data links that you might have as well here for that can be attached to reality mesh. So the reality mesh is giving you that great review tool, that great insight for you then to attach any information to that you want to. And also, it's just some of the tools that we have available in the CAD platforms is, you know, you can mask and clip your reality mesh with a click of a button, really get an idea of the condition of that asset, what it may be. And we can also, as you saw before with the road design, we can really easily, you know, add new 3D content on top as well, things like that. So we can bring in a new pump design like so. And to add to that, the great thing with ContextCapture and the fact that obviously these reality meshes are built all from images is we do try and say, you know, use them images again, make sure you keep them. They're a great track record. They do offer as well. So here what we have is we have the reality mesh in there, but what they want to do is get even higher detailed. So what they do is they go and look at the original image taken to create up that section of reality mesh. So great way to review your points. Skip that, it's a bit old. So as you can see, there's lots of different ways it can be used. That was just a very, very short snippet of how ContextCapture is utilized in terms of reality meshes more in a civil and a little bit of industrial, but we do see people across the board using it in every different sort of aspect of engineering. And then what I wanted to just finally finish with is a little bit of what's coming in the future with ContextCapture. So, and what we have is ContextCapture Insights. And what ContextCapture Insights is our AI version of ContextCapture. So it's all about machine learning. It's going to be a bolt-on module for ContextCapture that will be coming out soon. And it's a great way for infrastructure owners to see, like what we did before, is when you select classification, right now it's more of a manual piece. What we can do now is through ContextCapture and in ContextCapture Insights is we can actually automate all of that classification, automate the detection of assets using ContextCapture. So here what they do is they are looking for things like motorbikes, or you saw before with telecommunication towers. And how this works is it can be whatever you want to tag. So you could take images of, I showed before, the industrial site very much thing where they might go and tag things like gauges or valves or pumps, etc. And once you've created your detector, it gets created again in the cloud. You can then run that detector on every data set. So if you were just industrial, just an example, you did go and capture many of them sites like you just saw then a minute ago, what would happen is once you create that detector, you keep going out on site again. This time there's no more creation. Everything's run automated and it classifies that reality mesh for you. So it's a really powerful tool for the asset management side of things, but you know, a great way for people to get an idea of what's on their sites and what might classify them. And we are working heavily as well on how this will be used for vegetation and also for ground extractions to improve them along the way. And then a final big piece that will come with ContextCapture Insights as well is defect detection. I think this is going to be the most popular piece when ContextCapture Insights is released in the coming months. And the idea with this is the same as we saw before, where you could create these for working with asset classification. ContextCapture Insights will also do it for defect detection. So with defect detection, what you can do is you can obviously identify cracks, identify rust, monitor defect evolution over time, a long time. Sorry. So the idea being is someone who might be an inspector doing lots of inspections of, say, bridges, overpasses, things like that. What they'll do is they'll got their capture images, they'll create their reality meshes, and then once they've created them reality meshes, they can run their defect detections. And what will happen is ContextCapture will extract all that information, will extract them defects for you. for you to review, and then once that's been extracted, you can then work with them. So as you can see here, all the defects here are in green where it's had cracks along the section of a bridge, and then you can work with obviously how appropriate they are for you. But really, really powerful, great tool. And I think I was going to say this question, but obviously it's live. So that's it from me. I hope it's been of interest to everyone. I hope everyone finds this an interesting topic as I do, and that we do get some more users for ContextCapture. I'd like to thank everyone for your time, and I'll hand it back over. Thank you very much.
Кирилл, если хотите, мы можем вам дать голос, и вы сможете задать голосом вопрос Джерарду. Gerard, we have one question to you. Are you here?
Yes, I'm here.
Okay, thank you. How to use meshes from CC in GIS? Maybe you can see in chat. It's a question from Kirill. Do you see it or no?
Yes, I can see that. Yes. So yeah, ContextCapture meshes in GIS. Basically, a way that we would advise on our side that we use that is we do have a software called Bentley Map. Bentley Map utilizes ContextCapture meshes very well, and it can be used to update your GIS platforms. I don't have anything to hand now to show. I can obviously forward some things on later, but we do see lots of people using the meshes to help sort of work out new GIS layers, update GIS layers, and also use the meshes for detailing classifications for GIS and things like that as well. And that's all through Bentley Map.
Окей, thank you. Кирилл, возможно, если хотите, я могу включить вам голосом, и вы сможете еще спросить. Коллеги, если у вас есть вопросы, пишите. Окей, поднял. Минуту. Кирилл, у вас есть микрофон, вы можете сейчас включить звук.
Hear me?
Yes, we are hearing you.
Okay, great. So, sorry, I haven't got the name of the GIS you mentioned. Is it possible you to send it via our chat so I can clarify this? And my question was, if my customer is not a Bentley user, can he use, for example, Esri software or another kind of software and incorporate 3D meshes from ContextCapture inside its environment, GIS environment, and integrate it with other data from vector data and from databases, etc.? Thank you.
Yes, we do create, I can't remember, sorry, of the exact format name off the top of my head, but we do create the Esri, the format, one of the output formats for ContextCapture meshes is the Esri format, so that can be loaded that way. So if you wanted to go through Esri, you can go through that. Obviously, if you're not a Bentley user, then ignore the Bentley Map side. But if you're an Esri user, then the ContextCapture meshes can be exported into the Esri format.
Okay, thank you.